All right, so I've given you your choice. So first I want to see what choice you made. You gotta choose one of them. There's three possibilities: graph and check, substitution, or elimination. Give me a thumbs up if you use the method called graph and check to do the work. Good. Give me a thumbs up if you used substitution. Give me a thumbs up if you used elimination. Okay, put your thumbs down. Okay, so that just tells me what you did. Let's see who got the right answer. What is the correct answer? Got a lot of confident people. We'll start with Alicia, Hezekiah, Catalina, and then Sebastian.
6,
Okay.
8, 6.
Okay, so we have a disagreement.
6, 8.
So you agree with Alicia, Sebastian? Okay, so we do have a lot of disagreement going on. Kamoy and then Zavari?
6, 8.
Seems to be a little more support for that. 10, 16. We got a lot of different answers floating around. Sharik?
I agree with the 6, 8.
6, 8. The correct solution is 6, 8. Now, you could have done it any way you would like. No matter what, if you did it correctly, you should have gotten 6, 8. However, there was one method and one detail in that method that was by far the easiest. I'll give you a hint. The method was elimination, but you also had to do it right. So what detail did you have to use to do elimination to make this super easy? We'll start with Maria.
Multiply the first equation.
What did you do, Alicia? So they found the magic. If you multiply the first equation by 4, watch how easy this becomes. That becomes 2x plus 3y equals 36. The bottom equation stays. And now you are set up perfectly for elimination. This disappears and you get 4y equals 32. And so you get y equals 8. Plug it into the second equation, solve for x, and you've got your x coordinates. Now, there was quite a few other ways you could have done it, but in my mind, that was by far the easiest. Brandon and then Shu. By -3/4. And it worked out for you? Okay. And so that's totally fine. One issue for me is that you end up with a fraction here, and then you have to add fractions, and even though you should be able to do it, it makes a lot of people uncomfortable. So go for it. That's awesome that you were able to get it right that way. Sharik and then Sebastian?
It was actually kind of easy. Like, when you multiply the first equation by 4, you can also just divide the second equation by 4, because it would be the same thing. It would be -1 half x plus 1/4 y equals -1.
That's right. You could have also divided the second one by 4 as well, and that would give you opposites here. It would give you 1/4 here, and this would give you -1. So it actually works out fairly nicely that way as well. Sebastian and then Alyssa?
I got the wrong answer, but I found out a mistake on the first equation instead of looking at 4.
Okay. Now you could have still, so you multiplied by 2 and then you tried to use elimination? Okay. But there was nothing to eliminate if you multiplied by 2. So did you assumed it would eliminate and you just kept going?
I'm looking at like 2 and I got 2x.
Okay, so you just your brain kind of did like a little skip over. It's okay. It's an honest mistake. Alyssa?
Are you going to teach us Martha's rule? I think it's called.
What is it called?
Martha's rule, something like that. It starts with it.
Okay.
No, that's not.
No, you're thinking of a different thing. I'm not sure. You'll have to show me. Doesn't sound familiar. Is it something you read in our textbook?
No.
Something you heard about? Okay. So So it doesn't sound familiar, but it might be something valuable to us. So I'd like you to show me, and then maybe it's something I should share. Okay? Good. Any comments, other comments or questions on today's warm-up? Good. So we're doing well so far. We've been studying for the last week or so linear systems. We should have a pretty deep understanding of what they are, what they look like, how to graph them, and how to solve them. And specifically, when we do solve them, what it is we're looking for. So today, we're going to throw something else into the mix. So you're still going to have to do everything we've been doing, but now we're going to include some special cases. Before we get to the special cases, let's just quickly review what you do know. What you've learned so far is that a system is supposed to have one solution. And that's because the lines intersect. And that point of intersection is called a solution. And when we write it out on our papers, if we're asked for the solution, we write something like this, an ordered pair. So that's what you already know. But now we have two special cases. What if we were to have a system that when we drew the graph actually came out to parallel lines? Well, if a solution to a system is the point of intersection, that's a problem in a set of parallel lines because parallel lines never cross. And if they never cross, how could they have a point of intersection? They can't. So if we end up with parallel lines like we have here, then we have no solution. Here's what it looks like when you're actually working out the math using substitution or elimination. We will end up with an equation which is where the two sides are not equal to each other. So we'll end up with two numbers that are not equal. And that will tell us that there's no solution. So, ideally there's one solution, but if the lines are parallel and they never cross, there's no solution. Finally, we have another case. What if we had two lines just like we have here, except instead of them being parallel, they're actually the same line two times. If we have the same line two times, this is what it would look like. Now, it looks like one line, but in actuality, this is two lines, one lying on top of the other. You learned quite a while ago, especially when we were studying standard form, that you could have many, many different forms of an equation, but they were all the same equation. They all had the same graph. Well, if we have a system with two equations that are exactly the same, then we end up with lines coinciding. And this is called infinite solutions because every point is a solution. Because every point on the line is a point where the two lines are crossing. Remember, if these are two lines on top of each other, then those two lines are touching right there, and they're touching right there, and they're touching right there. They're touching everywhere. And everywhere it touches is a point of intersection. And that will continue on forever going up, and it will continue on forever going down. And that's why we use the word infinite. Here is what it will look like when we're doing substitution or elimination. We will end up with an equation with the same number on both sides. That will tell us that it's infinite solutions. Does anyone have any questions or comments so far? So we're going to explore this idea by looking at a system two different ways. So we are going to, in example 1, solve this system by graphing and then we're going to solve it by doing substitution. We want to see what happens both ways. So let's first start out with graph and check. That's the first method we're going to use. Now, you're going to have a quiz on Friday on all the different methods. So let's see who's got at least a good jump start for that. What's the first thing we need to do to graph and check? What's the first thing we need to do? Ania? Good. We want to do what? Isolate what? Okay. Good. So that's a good start. Someone want to say something different or add to that? Shelby? Put what? Good. Yeah, we want both equations in slope-intercept form because we want to graph both of them. And so we have to put this in slope-intercept form, and then we want that in slope-intercept form. So Ania was right. We want to isolate. I think maybe she was thinking of substitution, but she had the right first idea. Right. Yeah. So what's in first equation? What's the first thing we're going to do to get it in slope-intercept form? Sebastian? Add 6x to both sides, and we'll end up with 2y equals 6x minus 8. And how do we get it finally in slope-intercept form? Ania? Divide everything by 2. Very good. And so we're going to end up with y equals 3x minus 4. Now we also want the second equation in slope-intercept form because we want to graph both of them. What do we do to the second equation to get it in slope-intercept form? Tristan? Very good. We're going to add 3x to both sides, and we got y equals 3x plus 7. And so the original system still is intact. It just looks a little bit different because now they're both in slope-intercept form.
Why don't we just divide the intercepts?
We could have. You just want to find the intercepts for the first one, the intercepts for the second one, and then draw lines to them? Yep, you can absolutely do that. Okay? But there's a value here that you're not going to get from doing that, and you're going to explore that in a couple of minutes. Yes? Well, in this case, yes, but in the future, I'm going to be leaving it up to you. Okay?
Don't we just tell it's that they're in the solution? Since you can only tell them y 3x minus 1 is not the same as y 3x plus 7.
Okay, so this is the kind of thing that my students need to start exploring for themselves. So some of you have already picked up on something, some of you have not. So we're going to finish the graph, which is not really that hard at this point. But some of you already instinctively know what's going to happen. Let me start with the blue equation. We go to negative 4, 1, 2, 3, 4, up 3 over 1, up 3 over 1, and we'll draw the line. And then the green one, up to 7, 1, 2, 3, 4, 5, 6, 7. Up 3 over 1. I can't go any further up, so I'll go down. Down 3 to the left 1, and that will be fine. So you should have a graph that looks like mine. you, as Sharik and Catalina were trying to indicate, knew what was going to happen just by looking here, and you actually didn't need this. I am asking you to do it right now because we're trying to explore all the aspects of this, but for the future, once you know the answer that I'm looking for, then you can stop and you don't have to do anything that's not necessary. So I am looking for the number of solutions. That's what I'm asking for. So is there one solution, no solution, or infinite solutions to this system? What do you think, Kayla? No solution? What did you think, Alyssa? Yeah, there is no solution to this system because the lines never cross. Parallel lines, no solution. Does anyone have any questions on how we did that? Okay, so now let's look at this same exact system, but let's look at it in a different way. Let's explore what happens when we do substitution to the same system. What is the first step in getting set up for substitution? 2 people remember, 3, 4 people remember, 5 people, 6 people, 8, 9 people. Go ahead, Maria. Okay. Good, you said that beautifully. So which equation do you think would be easiest to isolate? And which letter? Good. Not only that, but it's already done for us. We had to do it here. So that will be the result of isolating the y, so we already have the first step done. So here is what the system is. We've got negative 6x plus 2y equals negative 8, and we isolate the second one, y equals 3x plus 7. And now we are ready to do substitution. Negative 6x plus 2 times this expression equals negative 8. So we put the 3x plus 7 right here, and now solve. And you should pretty quickly see something. Your spidey sense should be tingling already. What do you notice? Sabari?
It's that the 2x's cancel each other out.
Yeah. This is going to cancel this out, and we're left with this equation, which is not a true statement. 14 does not equal negative 8. And so what happens when we end up with something like that? What is that called? Timkai? No solution. Very good. So we've seen it represented in 2 different ways. We've seen it represented through the substitution method, and we've seen it represented through the graph and check method. Same result. We knew what was going to happen. We knew it was no solution already. But we wanted to be able to see this. This is the answer. This is the evidence. Okay? Comments or questions on example 1? Go ahead, come on. Absolutely. Absolutely. And that's one nice thing about having the 3 different methods at your disposal is they complement each other and you can use one to check another. In fact, one of your classmates told me that they felt like they were getting the wrong answer in the last homework, and then they used substitution to redo it, and they found that they were getting the right answer more frequently that way. So that was an example of someone using both methods to their advantage. Okay? Any comments or other comments or questions? It's a little early in the game, but let's see how you do on your own. Checkpoint number 1. Use substitution to determine the number of solutions. So I want you to tell me one solution, no solution, or infinite solutions. Okay, let's survey, since there are only 3 possibilities. Give me a thumbs up if you think there is one solution. 1, 2, 3. 3. 1, 2, 3. Good. Put your thumbs down. Give me a thumbs up if you think there is no solution. 1, 2. Okay, put your thumbs down. Give me a thumbs up if you think there are infinite solutions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Put your thumbs down. So overwhelming majority think there are infinite solutions, but we had some people who thought other answers, and there are.
Yes!
Holy
So, let's see what we did. I asked you to use substitution. So, which equation did you isolate, and what does it turn into when you do the isolation? Go ahead, Kamoy.
Y equals, I say and it's y equals -3x plus 4.
Okay, so this turns into y equals -3x plus 4. Very good. Good. So now we substitute into here. We do some work, and then we end up with something. What do you end up with after you do all the work? What do you end up with at the bottom after you do all the work? Brandon? No, I'm saying after you do all the work, what do you end up with? Okay, what did you end up with, Alyssa? You should have ended up with -8 equals -8. And if you get the same number on both sides, that means infinite solutions. Okay? Now, some of my even higher level students might have picked up on some other things. Anyone pick up on anything else? Eric, we'll start with you, and then Shelby, and then Catalina. Well, go ahead. Say whatever you're going to say. You got 0 equals 0. Did you use substitution, or did you use elimination? But you picked a different variable to isolate? Then you got lucky or something. If you did the exact same isolation, if you did this and plugged it back into here, then you should have gotten -8 equals -8. So I'll have to look at your paper to see what you did. Okay, Brandon, Ania, and Kezekiah, and then Anissa. Brandon. Oh, I apologize. Catalina was first. Catalina, and then Brandon.
I thought it looks like the exam.
Okay,
That's right.
okay. But it has a different result because the example we did was no solution. This was infinite.
Oh, but it's only like one number difference.
Okay, that's true. It does look very similar. Brandon?
I eliminated the choice in between one solution because I figured out that they have the same solution.
Okay, so that's an important detail that I was hoping a few people picked up on, and by the reaction of some other people, I'm guessing they were hoping to say that as well. And what did you pick up on? Okay, so opposite of A over B, so we've got -3 as the slope. Opposite of A over B, you end up with the same slope. So something was going on there as well. And there's more to it. Ania? Okay. Okay, Kezekiah? You were waiting?
Oh,
Okay, I'll come back to you. Shelby? You thought it was the opposite of the one we did before. Okay, interesting, and that's similar to what Catalina was saying. Kamoy, and then back up front. It does? I know, I love doing that to students. Probably my favorite part of the day. Example 2. Now we're going to take the idea of one solution, no solution, infinite solutions, and see how it applies to a real-world scenario. So everyone write example 2. You do not have to copy the text of the question, but you must read the question to yourself. It should take you 30 seconds to a minute. So we have a real-world scenario, a little bit different than the ones we've explored so far, and we'll talk about what that difference is in a little while. But we're being asked something a little bit different than what we've been asked, which is there enough information to figure out the cost of admission? So I'm not asking you for the cost of admission. I'm asking you, is there enough information to find it? Here's why you're being asked a different question. When we have a system, there is the possibility of these two special cases, no solution or infinite solutions. If that comes up, then that poses a problem because we then can't actually find a solution. Now here's the weird thing. Admission to the water park does cost money. Renting a tube does cost money. So I'm not making that up. But it is possible that the information would not be set up in a way that we would actually be able to find those pieces of information. They exist, we just might not have enough information to find it. So our job is to figure out, is there enough information? Sebastian, you had a comment or question, go ahead.
This question seems familiar as the question.
Okay. Okay. So we'll look at that afterwards. All right, so before we can actually figure out if there's enough information, we need to set it up. So I'm going to do something that I don't usually do. This is an example. It's not a checkpoint, but I'm going to actually ask you to set up the system. You've got a minute and a half, and I would like you, on your own, to write the system that represents this real-world scenario. Go. Okay, give me a thumbs up if you wrote any system. You just wrote a system. Give me a thumbs up. I'm not saying whether it's right or wrong, I'm just saying if you wrote. Good, put your thumbs down. Stephanie, what was the first equation in your system? 15x plus 8y equals this number right here, 263.25. Okay, give me a thumbs up if you wrote that equation like she did. A lot of people did. Good, put your thumbs down. Catalina, what was your second equation? 20x plus 13y equals the other big number, 358. Okay, give me a thumbs up if you have that equation in your system. A lot of people. Looks like just about everybody. Put your thumbs down. That is exactly the system that I wrote as well. So, good job. I'm pretty darn impressed with this class. So now, we need to figure out if there's enough information. And the only way to do it is to at least solve it part of the way. So that's what we're going to do, is we're going to solve this part of the way. Any comments so far? Now let me rewind for a second. So far during this lesson, we've used graphing, we've used substitution. What's the only method we haven't used yet today? Alicia? We haven't used elimination. So we're going to use that for this question just to see what happens. So this is going to be a bit of a tough one. So what could we do to set this up for elimination? Suggestions. Tristan, then here, then here.
Multiply the top, the first equation by 4, and then the second equation by negative.
Okay. First one by 4, and the second one by -3. What is that going to get us, Tristan? Like, what will that achieve?
60 x plus.
But don't tell me what it will equal. I'm telling you what goal will that achieve.
It'll be 60x, and the second equation will be -60x.
It will? Oh yeah, look at that. Oh, that's pretty nice. I like that. Okay. Wow, that's pretty brilliant. That's not what I did. That's much nicer than my way. Hezekiah, what was your idea?
Stone.
He stole it?
Exactly.
Well, he didn't steal it. You both had the same brilliant idea at the exact same time. He happened to go first. Sharif?
Same idea.
Same idea. Okay. Anyone have a different idea of how we could go about this? Shelby and then Brian? Okay. Divide them by something. So you could divide them, and that would end up getting this as opposite. This would be 5x, and that would be -5x, or something like that. Yeah, that would also work. This would get a little messy here, but you could absolutely do that. In fact, what I would like you to do is, while the rest of us do this way, I would like you to try your way, okay? Because I want to see how it works. No, because I think that's very creative, and you're the first person out of any of my students to bring that up. So I'd like to see how that comes out. Brian, you were going to propose something else?
No, just out of curiosity, did you multiply by 8?
No, I did not. I multiplied by -20 and +15. Because usually what I do is I try to find the quickest and easiest, and so I just did the opposite of this times that, and then this times that, and it will get opposites. So, which works, but the numbers get a little bit bigger, and it's a bit of a pain. So, I think the idea proposed is a really good one. So let's go ahead and rewrite the equations. So this is going to be 60x, that's going to be 32y, and then this will become, I'll need my, you already got it, Alicia? What does it come out to? 1,053, which worked out really nicely. Because there was a decimal, and now all of a sudden there's not. That was really nice. And then the second equation will be -60x minus 39y equals, did anyone already get it? Alyssa? -1,074. Okay? So that actually worked out really, really nicely. And so now we're ready for elimination. So we work down, this cancels out, and we get -7y equals -21, which is unbelievably nice, and it comes out to y equals 3. So we got the y coordinate of the solution. So now maybe we can answer the question, do we have enough information to find the cost of one admission?
Yeah.
It's a yes or no question, but you got to be able to explain. What do you think, Kayla? Okay, well, let's start with yes or no. Yes, okay. Now someone explains. Go ahead, Alicia. That's right, that was a great explanation. Now if we just take the 3 and plug it in right there, we could solve for x, so we can absolutely solve for one admission. So we have answered the question. The question is a big fat yes, we do have enough information. Does anyone have any questions on how that worked? Or what happened, or anything at all? Kumoy and then Kelly?
Can't you just have a code if you could, if there's no information, I just, I can write the equation.
No, because what if we ended up with a case like this, where we write two different equations, but then it actually turns out that they're really the same equation. We cannot solve this for x and y. We can't. There's no way to. We would need more information to solve for x and y. So if we somehow got the information in such a way that it was really multiples of the same thing, then we would have trouble. We would have trouble finding the solution. Okay? So it's a good point. You got a question or comment?
I put my hand back down.
Okay. Any other comments or questions? Okay. Shelby, were you able to complete it your way? You're still figuring it out? It's a little bit harder. Okay, but I really thought it was a creative idea. Like I said, it should work. But yeah, it might be a little bit harder just because the numbers might get a little wacky. Okay? I had a student in the other group who suggested something different that worked. He suggested multiplying the second equation by negative 0.75. And that actually, so you actually only had to multiply one equation, and it actually worked out brilliantly. Multiply by negative 0.75 because that turns that into a negative 15. 75% of 20 is 15. So he was able to figure that out. That became opposites, and then the rest worked out beautifully. So there's many different ways to solve these. Brandon? 9.75.
Oh.
You didn't think I was going to be able to say that right away, right? You thought I was going to. Okay, so let's see how we're doing so far. Now I'm giving you your choice during the checkpoint. Use substitution or elimination. Pick one method that works for you, and I want you to tell me how many solutions there are. One solution, no solution, or infinite solutions. You've got 2.5 minutes. going to do this by survey. Give me a thumbs up if you think there are infinite solutions. Thumbs up if you think there are infinite solutions. Thumbs up if you think there is one solution. Thumbs up if you think there's no solution. Everybody thought it was no solution. There is no solution. So, comments or questions on this one? Did anyone discover anything as you were working on this one? Ania, Alicia, Anissa. Go ahead. Okay, so they both cancel each other out. Good. Okay, so you immediately noticed that there was a multiple going on. That this was actually just a multiple of this one, or the x's and y's. Very good observation. Anissa. Same thing? Okay, very good. Hezekiah and then Ann? They have the same slope. Okay. Very, very important. Very important observation. Very important observation. Ann, what was yours? He stole it. Okay, so then do this for me. How did he know, or how do you know that they have the same slope? Okay, very interesting. It's the opposite of A over B. So the opposite of A would be negative 6 over B, which is negative 2. So that equals 3 for the top one. And then the opposite of A is 3 over B is 1. That also equals 3. And so she was quickly able to figure out that they had the same slope. That's important. But then she went a step further and put them in slope-intercept form, which also tells us the same thing, but gives us more information. I ask you to put your hands down for a second, because this is going to lead us into the last example. So, example 3. Now we want to look at it a little bit differently. Without solving, in other words, without using graph and check, without using elimination, without using substitution, how many solutions are there? So, basically, the idea has already been proposed. It was basically proposed by someone within the last few minutes. So what could we do with this system so that it's not solving the system, but it gives us all the information we need? So what could we do? Alyssa, and then Kamoy, and then Sharik? What's that? Okay. Kamoy, Sharik, and then Ann? Okay, finding the slope will tell us some of what we need to know. Very good. And Ann basically just reminded us one way of doing it. Sharik?
Basically what Moy said, use the opposite of A over B to find the slope. If they have the same slope, we know it's either infinite or one solution.
Okay, what if they don't have the same slope?
Then it's automatically one solution.
Okay, very good. Ann, you want to wrap it up together? Okay, but, so he said, if they have the same slope, then we know it's no solution or infinite solutions. So then what should we do to figure it out? You said it when we were talking about the checkpoint. That's why I called on you last, because I knew we'd come back to you. You did something during the checkpoint. Yeah. If you put it in slope-intercept form, we can tell whether they have the same slope, and we can also see if they have the same y-intercept, which will give us all the information we need to make a conclusion. Okay? Yes, Brandon. You're right, but that does leave you hanging a little bit because that will only tell you if they're the same equation. What would you then do if they weren't the same? Then you'd have to convert it again. So you can do that. Absolutely, that's a great idea. Especially if they're already in standard form. That's something quick you can do. Some of us can do that mentally. But look at the second equation here. It's not in a very friendly format, and so we don't want to have to convert it twice. So I'd like to stick with Ann's advice. Let's put them in slope-intercept form. So what do I need to do to the first equation to put it in slope-intercept form? Zabari? Subtract x from both sides. We get negative 3y equals negative x plus 7. And what do I need to do to finalize that, Brian? Divide everything by negative 3. And so we end up with y equals 1/3 x minus 2 1/3. What can we do to the second equation to get it into slope-intercept form? Come on, start us off.
If you had put that just like divided by 4, like right now, it'll come out to the same equation. Wait,
Well,
I'm wrong.
unfortunately, that would tell us some things, especially for us higher level students, but that will get the x isolated and it won't be slope-intercept form. So what can we do to get it into slope-intercept form? Kayla? Yeah, the easiest thing to do is subtract 28 from both sides, and we get 4x minus 28 equals 12y. And then how do we finalize it, Catalina? Divide everything by 12. And we will end up, even though it'll look backwards, we'll end up with 1/3 x minus 2 1/3 equals y. And then if you just take the y and the equal sign and move them over here, you can see that they are actually the exact same equation. So this tells us everything we need to know. So how many solutions are there? Well, everybody's hand should go up. Everybody should know. How many solutions are there, Anissa? Eric, you agree with that? What was it? Yeah, there's infinite solutions because it's the same equation. Does anyone have any questions? Any questions? Anne and then Anita? Sure, why not? That's fine. As long as you answer the question that I'm asking, I really don't care how you do it. I've told you before, you could use magic. I wouldn't care. If you can give me the correct answer, as long as you're doing it yourself, and you're not cheating in any way, I don't care.
I could use my unicorn.
Okay. Why didn't we convert it and then I didn't hear what you said? Times the first one by 4 to see if it came out the same. Well, that's what Sharik was suggesting and Brandon was suggesting. You could. That'll tell you a little bit, but it won't tell you everything. This tells us everything. This shows us the same slope and the same y-intercept. That tells us it's the same equation and it's infinite. If we leave it in standard form, we could easily find the slope, but the y-intercept you would have to find also. Okay? Good. All right. Draw a line across your paper. Your classwork is page 79. You're going to do numbers 26, 23, 20, 14, 11, 9, and 5. You got little over 15 minutes. All right, pick up your colored pens and let's see how we're doing. Number 26. A is down here at the bottom. That's the system. When you solve it, you get infinite solutions. And so can you figure out the cost of each kind of ticket? No, because you don't have enough information. The publisher talks about it being one equation being a multiple of the other. What we talked about is the fact that they're basically the same equation. So if you said something about it being the same equation, or if you said a multiple of the other, either way is fine. Number 23 and 20. (14 and 11). Then you were asked to graph and determine the number of solutions, and here's what those two look like. Any comments or questions on any of them? That's right. And so, here's the thing. On your quiz on Friday, I may ask you to graph something and then tell me how many solutions. If I give you a grid to actually draw the graph, then you have to draw the graph. If I don't give you a grid, then you can do whatever you want. So what Alicia did was very smart. She started working on this to prepare to graph, but she ended up with the same equation twice. And then she immediately knew what was going to happen. She didn't have to go further. Okay? So you really just have to pay attention to what you're being asked. If I'm asking for the graph, then you have to give me the graph. If I'm just asking for how many solutions, then do whatever you want. Okay? You have a comment or a question or? Okay. So what method did you use?
I used substitution.
Okay. So here's what I'm going to ask you to do. Now I want you to try elimination. You now know the answer, so see if you can do it by doing elimination. So don't erase it or anything, just use your colored pen off to the side and see if you can do it doing elimination. Because you should notice something about this right here and that right there. Okay? Hezekiah and then Anita. Okay? Then something you made a mistake somewhere along the way. What method did you use? Yeah, it's set up really nicely for elimination. If you multiply the top one times 2, you end up with the opposite here, but then you also end up with the opposite here, and then you also end up with the opposite here. So you made a mistake somewhere. You end up with 6x plus 4y equals positive 8. Everything is opposite. This will cancel, that will cancel, and that will cancel. You end up with 0 equals 0.
I didn't put on the second equation, I didn't put the negative.
Okay. Ania? Okay. That's fine. All right. Draw a line across your paper. Your homework is on page 474. You're going to do 12 through 30 even. You're going to do 36, 38, and 42. Then you're going to do the EOC prep, days 1 through 5 on FL 15. Now, a number of people have said to me, Mr. Gallup, we never learned how to do these types of questions. So you are going to read these pages right here. Read pages 73 and 74, and that is going to explain the Venn diagrams to you. Then you're going to read the next section, and then you are going to prepare yourself for the quiz on Friday, which will be 7.1 to 7.5.